Hi guys, welcome back to the channel. Today in Bash we would be demonstrating loops. In Bash scripting, various kinds of looping structures already exist. Some of these structures you might be already be familiar with. Some of them are for, while, until and more. So yeah, let's just get straight into it. I am presently located within my present working directory, which is termed as looping for the purposes of this video. So yeah, so there are different kind of looping structure. The for loop is one of those looping structures which basically iterates over a range of items or a list, while the while loop basically runs as long as a specific condition remains true. uh, this is a conditional looping structure. Similarly, until is also a looping structure which would basically run as long as the condition remains true. Similar functionalities in case of looping is seen for while and until, but they differ in terms of structural capacities. So yeah, let's just try to dive into these structures more. So yeah, let's just create a loop. Okay, let's just create for loop.sh, something like this. My bash script basically would look like this, and let's just import our bash interpreter into our script. So yeah, the for loop is, as I previously mentioned, is a looping structure which can basically perform a number of iterations, and these number of loops are already predetermined. Basically, it can be a range of numbers or a list of items, and therefore we already know the number of iterations that the for loop would be performing. So let's see the syntactical structure, where the entire for loop basically looks somewhat like this. We basically use a variable value which would basically be doing a set of commands for execution until the loop has been completed. So let's say we want to right now iterate over a list of items with the help of for loop. So let's just say let's just define a variable called fruit in a list of items called, let's say, apple, banana, orange and mango. Let's set this up like this, and let's say I write a command echo I love, I guess, $fruit. So yeah, let's just try to execute this. So we'll write bash for.sh. As you can see, we have successfully looped through each of the elements, which are apple, banana, orange and mango, which we set it up, and all of these values were stored at a point within the variable fruit, as the for loop executed one of the iterations one by one, as we basically move the flow of control through each of these items. So yeah, the echo command would basically print out let's say the statement, as we can see here, I love $fruit, and therefore the value fruit is basically getting replaced by the item value, and therefore this structure would successfully execute each time as we pass through the list. So yeah, let's just try to modify for.sh in order to accommodate range of numbers. So let's say we want to iterate through a bunch of numbers. So for that, you basically would require to set up a range value within curly braces, with the starting and the end numbers basically being specified before and after double dots. So these this structure basically indicates that we would like to basically move or begin with the first number followed by the last number till this iteration continues in a consecutive, iterative, incremental format. So let's set up our value like this, followed by our echo statement. Let's modify it to showcase number, and let's just give some chevrons, and let's just move into num. So yeah, so this would basically do the same function as before. but instead we would basically be getting numbers for this specific um, s- um, um, looping structure. So yeah, as I have previously mentioned here, 1 to 5 basically generates numbers starting with 1 till 5, and the loop would basically move once over each of the numbers, and all of these values are basically represented within num, and they get basically printed out into the terminal at each iteration. So yeah, another thing about the for looping structure is that in case of numbers, you also have the option to also specify a step value. Now a step value or a step increment value here is used to basically increment our values from the previous iterative number to the next iterative number by skipping a set of numbers in between. So let's say if we want to move from loop through the list of numbers starting from 1 to 10, and here we would like to exclusively only showcase odd numbers. So for that we can set up something like this. So here we would like to skip over each of the even numbers, and here we would specify 2 as the step value. So whenever we do this, we would be skipping over each of the even numbers, because the step value basically allows us to basically skip these values. However, this is not typely defined, and this can be modified to any step value, so it could be 3 and so on. So we can try once again, and you can see that we have successfully incremented all the numbers numerically starting from 1 till 10 with the help of our step value, which basically skips over 2 numbers at a time throughout the iterative process. So yeah, this is one of the best uses of for loop, and this looping structure would come into play whenever we are expected to work with other files. So let's say we will clear our file our terminal, and let's just set up bunch of text files, and we would like to let's say loop through these files. So for that I would have to create some files. Let's say demo.txt. So let's just say demo1.txt, demo.txt, and demo3.txt, and yeah, let's just create this. So here you will see that if I type ls, or let's also create some okay, let's just write ls, and let's just try to get hold of all the files which end in the extension .txt, and once you hit enter, you will see that we are successfully able to retrieve those 3 files. So if we are able to print out the values which are being depicted here, for that we can basically show this off in for looping structures. So let's just go back into our bash script, and let us set up a file. Let's just say for file, and let's just set it up as dollar followed by a parenthesis. So here we are basically executing the same command that we just executed out there in the terminal, but here instead of getting all those values all at once, we would basically loop through them one by one, and we would basically print out, let's say, the names of these files into the terminal. So let's just give out files ending with .txt extension. So we have set something like this, and we will basically be able to retrieve the names of these files, as we loop through the for loop. So as you can see, just like before, we are able to basically uh, uh, return the names of the text files in our which are located within our present working directory. You can also modify this to for star dot sh files. So let's just try to do that. Let's just try to execute. So here you can basically see that this works as long as we have our intended file present within our present working directory. So yeah, moving on. Yeah, let's just now try to talk about a little bit about while loop. While loop is another controlled structure, looping structure, which basically runs iterations as long as we set a condition and that condition remains true. It is useful whenever a number of iterations are not known beforehand. So this can be like, let's just create a while sh. We will go into insert mode. We will import our bash interpreter into our file. The while looping structure basically has a syntactical format which looks somewhat like this. Um, when we let's just escape, insert mode. Yeah. The structure basically looks somewhat like this, whereby which we have the while followed by the condition which we establish within square braces and bunch of commands which are basically depicted within the do and the done. So yeah, let's just try to, let's say, count from a specific number, let's say 10, and basically count it down to 0. And with the help of while loop we can basically perform this action with the help of a counter operation. So let's just say we establish a counter, set it to 10. Always remember, whenever you assign your values to variables, there should never be spaces in between, otherwise it will not be recognized. And it's always a good habit to end with semicolons, depending on the kind of Linux distribution you are using. It might throw an error. So yeah, let's just set up our counter, and we would basically check the condition. If counter is greater than 0, we would basically perform a countdown operation, which basically would show out the current value of the counter. So let's just set that up, and we will set that to something like this. And always remember, we always have to decrease the value of the counter to get as close as to 0, and once we reach the value of 0, the condition would become false, and once that happens, the while loop would basically become false and we would exit out of the loop. If you do not if you fail to do so, we basically end up with a forever loop, and that's not fun. So yeah, let's just try to decrement the value here, and as you can see, our values have been set up. So what we expect to see here is the value starting from 10 and basically decreases by 1 throughout the iteration until it becomes 0, at which point the condition basically becomes false and we basically exit out of the while loop. And as you can see, the value gets printed out through the echo command and basically appears through the string countdown with the value of the counter. So yeah, the counter hyphen or counter minus minus basically decreases the value of the counter at each point. Now let's say we can basically use the same structure in context of, let's say, trying to enter a password, and in this case it would be a pretty annoying password setup because it would keep prompting the user as long as he until he basically gives up the correct let's say input validation. So for that, let's just try to not make a password input right now. Let's just set up some user input validation system. So let's just say user input .sh. Yeah, let's go back into our bash bin. Yeah, so let's just read a value, and we would basically ask the user to enter a number which is not let's say which is greater than 10. So something like this. So let's say enter a value greater than 10, and we would basically receive the value into the num variable, and here we would set up the condition that let's say $num we would ask that it has to be, if it is less than 10, we would basically check. If it is less than 10, then we would basically prompt the user that we would basically give it a message that user has inserted invalid input, something like this. Please enter a greater number than 10, some message like this, and we again would read the value from the user within the loop, and we would basically perform this action of iteration as long as the number is not greater than 10. So let's just do that again, and yeah, once and yeah, we would basically only exit out of the while looping structure until once the user inserts a value greater than 10. So yeah, let's just write a final message like you entered $num. So yeah, let's just, okay, yeah, let me just go in. Okay, I'll just set the semicolons at the end of each of these statements, because it's always a good idea to do so. Yeah, so let's just go ahead and quit bash user input.sh. Yeah, so here let's say if I enter a number like 8 and hit enter, you can see that we basically get caught up in the while loop, and it will keep prompting us as long as we give an input which satisfies the condition of the while loop, so as to keep the iteration going. So let's say if I enter -1, it will still say the same. So if it is 2, and it will say the same message, it will be returned onto the message board. If I write 15, you can see that the condition has finally been satisfied, and we basically exit the loop. So yeah, we can also perform this kind of looping in order to monitor let's say certain process statuses. So for that, let's just say we have let's say Apache. Let's say we will just set up Apache to run in our system. So first of all, we will just check the status of Apache. If it is running, let's just write this status of Apache 2. So you can see that Apache is inactive, so you basically quit out of it, and let's just clear the message board. And yeah, so let's just set up vi server or something like Apache.sh, and here the main task of this specific script would be to monitor the activity of this Apache process running in the background. So we would just set up our bin bash. Let's just do so, bin bash into this, and yeah, let's just write process name. Let's just catch this data name of the process into this process variable, and we will write the name of the process as Apache 2. Let's just say while we will get hold of all the processes with the help of pgrep, and we would basically redirect that information every 5 seconds into dev /null. So we can set that something like process $process name. We basically set this to dev /null. Yeah, and we go back to do. So here we would write echo $process name underscore name is running, and this would basically check the status and return this message as long as Apache is running. Else we will simply write $process underscore name has stopped. So yeah, let's just write and quit. If I go ahead and basically execute bash apache.sh, you can see that since we already checked the status of Apache 2, it's not there, it's inactive. So in order to activate Apache, you basically would do something like sudo system ctl, instead of stop it should be start Apache 2. Once I hit enter, I give my password, and in the background right now I have enabled Apache um, to run. So one more thing that I would like to do is to open a terminal, another terminal, and just let's just show. So yeah, just we would just right now run bash apache.sh. As you can see, we are basically getting the message Apache 2 is running. Okay, if I just move it a little bit so that it's visible, so you can see that the message Apache is running will keep on it will keep on being printed into the terminal as long as Apache 2 is active. And here we can basically check this status of Apache 2, and you can see that it is active and is running. So what happens if I stop this? So once I stop Apache, you would see that this particular script which is running in this terminal will basically stop, because the while loop, the condition would basically get will not get the process in the background, which is Apache 2. So in order to stop Apache, let's just try to basically stop it. So for that I will basically execute the same, let's just say systemctl, okay, so systemctl, and I will give stop Apache 2. So yeah, once I have stopped Apache, you will see that in this terminal the loop has stopped. This is because our while loop condition, which is just search, as you can see, our looping condition while pgrep process name, as long as if I write pgrep apache 2, okay, let me just process grep. Yeah, so as long as Apache is inactive, the looping structure would not return the required output once the condition becomes false. So that's one real world example of how you would basically run your script. Yeah, so let's talk about the until looping structure. So let's just clear our workspace. Yeah, so let's just write ei until.sh. I will import as always in bash. So yeah, until looping structure is kind of similar to while, but here it would run until the condition becomes true. So like, let's just set up until, sorry, it's not sorry, I made a small spelling mistake, until. So we will write until. The syntax structure basically would look like this. Condition, we will write the same structure as before. We will have a set of commands which will be executed, and we would exit through done. So let's just try to build the counter system as before, but instead of counting down, let's just say we want to count up. So we will write counter 1, and let's say as long as counter is greater than 5, we would basically print out counter, the value of counter, and we would basically, as before, instead of decreasing or decrementing, we would increment the value of counter, and we would expect to receive the value of counter being received onto the terminal as long as the until script basically executes. Let's just execute, and you can see that we basically counted up towards 5. So this pretty much explains how to count up. So let's just try to use this until looping structure, let's say in order to check the internet connection. So we would basically ping google.com, and we would basically try to get some message confirming that our process is, our system is in a way connected to the internet, so it's indirectly checking this. So let's just say something like, okay. So pinger.sh1, so we basically go into insert mode, just import pin/bash, and before I go into this, I would like to break down the use case of ping itself. So if I type ping itself, it's a kind of a command which is designed to check the let's say our connection to a specific website. So if I type ping, it would basically test the network connection, and it would send a small packet to a specific host, and basically returns for a response. And here if we just directly type ping google.com and hit enter, this thing will basically keep sending and receiving packets to that specific website. But here we do not want that, because we would be constantly being barraging a specific location with multiple pings, and that's not a good way to do it. So here we can basically use a -c tag into this specific let's just clear our workspace in order to make it a little bit more clutter free. So let's just if I give it -c, and let's say we would basically want to send one packet to quickly check without an excessive usage of the network whether this connection is established. And here you can already see that our destination is just a random Google server, just to check our our connection. We can basically store all of these outputs through a standard output to a specific location on my on my system, let's say dev null. These outputs are basically discarded and basically prevents my console from getting too cluttery. So let's just go back into our pinger. So let's just go into this back again. So what would be the structure look like? So let's just try to establish let's say until we keep getting our ping to google.com, any server on Google, we basically store that to our standard output location, which is null, and we would want to let's say if we have any standard error, let's say to a so yeah, if we get some error, let's say we would like to also discard that. So for that you basically write something like to um, uh, let's just set that to this. So yeah, this would basically make sure that any standard errors, if there are any, would also be sent to this specific location. So here we would write something like echo, and we would send no internet. So sorry, this is internet connection. Let's just say retrying or something. And here we would like to perform this action every 3 seconds, and once that has been done, we would basically exit and we would say internet something connection established, or some message like this. In this case, if I write dash finger reset, it would automatically just say the internet connection exists. But let's say if I just disconnect my internet connection, and let's just say I'll write bash pinger.sh, you would see that for the first 3 seconds it would just simply return me this message that it is retrying. So yeah, 3 seconds, it would take 3 seconds. So yeah, so the script basically would be pinging Google until a connection is available, and if there is no connection, it would wait for 3 seconds and it would continue retrying, and this basically would stop once the internet connection has been established. So yeah, this will keep on going on. So let's just say I will connect back my network. So yeah, you can see that the internet connection was established, and yeah, we just stopped our loop. So yeah, this is pretty much another way of working with until. If we compare for, while, and until, there are different use cases. So for loop is used for iterating over lists or ranges, while the while loop basically runs as long as a specific condition remains true, while we use until if we want a specific condition to become true, and that process will keep on running until that condition is not met. So yeah, I hope you learned something today, and this is how looping in with different looping structures basically works out in Linux, and I will see you in the next one. Bye.